Hello friends, welcome. Today we want to look at the equations of motions and how they are derived. You know that the equations of motions are very essential to solve problems that have to do with dynamics and kinematics in physics. Okay, so for us to be able to derive this equation, first of all, let's take for instance an object that is at rest that begins or tends to move and then wants to accelerate. For that acceleration to happen, there will be a time for that acceleration to occur before it's reaching to its final velocity and coming to a stop. Now, the u here represents the initial velocity in meter per seconds. The a stands for what? Acceleration in meter per second squared. And the t stands for what? The time in seconds. V is the final velocity. All right. So for us to be able to get the first equation of motion, we will try to know what is acceleration and then fix in the terms. Now, acceleration A is simply the change in velocity over time. Now, we know that change in velocity, a change in something simply means from the final to the lowest, the difference between them. So therefore, our final velocity is what? We can simply write this as acceleration A would be equal to V, which is final velocity, minus U, initial velocity, over T, time. Now we can cross multiply. When we cross multiply, we now have V minus U is equal to A times T will be what? AT. From here, we can make V the subject of the equation. V will be equal to, when minus U cross over, it becomes plus U. So U plus AT. And this becomes the first equation of motion. When you have questions that have to do with the final velocity, the initial velocity, and time, you can use this equation to find the unknown. For us to derive the second equation of motion, we must first of all present it in this way. Now, for an object which is moving either in a constant or uniform motion, for that object to have attained its final velocity, it must have had its initial velocity. So now the average velocity is the combination of the initial plus the final velocity. Average velocity, this is initial plus final velocity. You know the initial velocity is u and the final velocity over 2. All right, now, so substituting the first equation of motion into this, remember the first equation of motion states that v is equal to u plus at. So this is the first equation of motion. Substituting this into this, we will have u plus, now this v will replace it with this, u plus at. Now, solving further, u plus u becomes what? 2u plus at. Remember, this is over 2, sorry, over 2. Now, this is what our average velocity is. We simplify further. This becomes 2u over 2 plus at over 2. 2 will cancel 2. So we are left with u plus, this 2 here, we can bring it to the forward here. So this is half at. So let's take note of this. Average velocity is the same thing as speed. So, and we know that the speed is equal to what? Distance over time. Now this distance, let's represent it with S, and this is over T. So here that we see average velocity, which is also the same thing as speed, we can simply say S over T is equal to U plus half AT. Now we want S to stand alone, therefore we need to multiply, cross multiply. So X therefore will be T into brackets U plus half AT. Now X finally will be T times U is what? UT. When we expand this bracket, plus half AT times T will be half AT squared, because T times T will be T squared. And this is the second equation of motion. So the third equation of motion is gotten from the combination of the first equation and the second equation of motion. So let's derive the third equation of motion. It is very interesting. Now, if the first equation of motion, V, is equal to U plus AT, is stated down. Now let us square both sides. Squaring both sides, we will have V squared is equal to U plus AT all squared. Simplifying further, this will simply become U plus AT times U plus AT. Now let's expand this bracket. So we have V squared left here is equal to, what's U times U, guys? This will be U squared plus, what's U times AT? UAT. Now we have AT times U. This will also be plus UAT. And now we have AT times AT plus A squared T squared. Now simplifying, taking, collecting like terms, V squared will be U squared plus 2UAT plus A squared T squared. So it's very, very interesting. It's just mathematics. All right. So as we have gotten this, we go further by factoring out 2A from the last two terms here. So we want to factor out 2A from the last two terms here. We have V squared is equal to U squared. Now, plus, we want to factor out 2A from this. So when I write 2A out, I open a bracket. Now what will be left inside for this to complete UAT? So I will be left with UT here, right? Because 2A times UT will give me 2UAT. Now plus, here also I have A squared. So you know that when I'm taking out one A, I will be left with a single A. And my T squared will be here. But remember there is a 2. So for this to balance, I will have to take the half of this. So that when these two multiply this to it goes off, A times A will still give me back my A squared, and then I have my T squared. So now having this in this nature, now remember from equation, the second equation of motion states that S is equal to UT plus half AT squared. So it means that everything here, UT plus half, remember that this 2 here, if I should bring it to the front, it becomes 1 over 2. It will still be AT squared. So everything inside this bracket is the same thing as S. So I will replace this with S. Therefore, the final equation becomes V squared is equal to U squared plus 2AS. So this is the third equation of motion. So in this, we have been able to state all the equations of motion. The first one is V is equal to U plus AT. The second is S is equal to UT plus half AT squared. And the final is V squared is equal to U squared plus 2AS. We know that V is final velocity. We know that U is initial velocity, A is acceleration, S here is your distance or speed. Now, other terms here, T is your time, And with this, you'll be able to handle any problem that has to do with motion. Bye.